Let me now explain to you my model railroad control architecture. It all starts out with a PC, and the model railroad control software is installed to the PC. I'm monitoring the operation of my model railroad on two large monitors, each 15-inch. The control commands of the model railroad control software are transmitted through Ethernet to a digital model railroad controller, and this feeds power and digital commands to the tracks. If you have a very large model railroad with plenty of tracks and locomotives needing much power and more power than this digital model railroad controller can supply, then you can add a booster and, for example, divide your model railroad tracks into two electrical separated parts and then feed one part through the controller and one part through the booster. In my case, I did it a little bit different. I have up and running around 7 trains simultaneously on my 4,800 feet tracks, and the model railroad controller which I use has enough power to feed all these tracks and the trains and locomotives. So I use the booster to provide power and transmit digital commands to the drives and controllers, decoders in the turnouts, and to the signals with the associated decoders. By doing so, I have a very reliable power supply here, and I have a very reliable power supply here. If the model railroad controller software wants to know what track is occupied and what is available, it needs to get feedbacks from the tracks. Let's assume here that I have a track block with 3 sections. These sections are electrically separated. I'll come to this later on. And you have one section at the beginning of a block, another section at the middle of the block, and a third section at the end of the block. So if a train comes in here and goes on the first section, it will generate a signal to feedback modules. They are so-called S88 section status feedback modules, and they have each 16 inputs. I have 15 of these modules. If the train then comes to the middle section, again it sends a signal to the controller software, and finally at the last section. So for example, the controller software has command points that in a first section the locomotive gets a command to ramp down the speed to stop neatly in front of the red signal at the end of the third section. Another command point could be for having a very, very short train. Let's assume a locomotive and just 2 coaches. And you have a very long station platform. So if you would stop in front of the red signal, the passengers would have to run to the end of the platform to enter the 2 coaches. You want such a short train to stop exactly in the middle of the platform. So the model railroad controller software can have a command point in the middle section to stop the train exactly in the middle of the platform. This means in the model railroad controller software you have to configure how long in centimeters or inches this train is. So in this case, the command to the locomotive would be here: ramp down the speed and come to a stop here, and here is another in the middle, another digital command point saying, okay, train has to stop now, but has to stop in a way that this point is just in the middle of the train, so the locomotive may be here and the last coach may be here. I have divided all my 169 meter tracks, or 544 feet tracks, into 240 sections. So I need 15 of these S88 modules daisy chained by Ethernet. The last one connects with the S88 protocol and a very short cable to an S88 USB converter, and from there it goes into the PC directly to the model railroad control software. You could also connect this signal in the S88 protocol to the digital model railroad controller, and then these signals are sent via Ethernet connection to the model railroad control software. Now I took the direct way to have a very speedy reaction on changes in the status of all my track sections. I will now briefly go through the different components of my control architecture with the following slides, but I will keep it short because you can download this file. As I have said at the beginning, it is associated to this video, and then you can digest the content and look for technical details which I do not explain in the video, but only shortly touch them. Next thing is we will see and take a look on the model railroad software. This is from Freiwald Software. This is a leading world-class software for the model railroad computer control, and later on we'll take a look on how this works with a short video and some screen copies. The digital model railroad controller, which gets its commands from the PC and the software, the train controller software, is this one, and comes from the company ESU. ESU is a company also in Germany with a larger portfolio of electronics controls and specifically decoders for the locomotives of model railroading. In recent years they started to build very high professional, high value locomotives as well. The tracks and the rolling stock are from the German railroad company, model railroad company Märklin. Specifically, I must mention the C-type tracks, which are 3 rail tracks with AC power supply. This is different to the US, using 2 rail tracks with DC supply. I have many other locomotives from other suppliers like Rocco, Walters, Bachmann, Lilliput, ESU, and some more. And basically my gauge is H0, which is scaled 1 to 87 to reality. So far for that. In this slide, which I will not in detail explain, you'll see how it works to get the section feedback signals, whether a section of a track is occupied or available. You need to do some mechanical work on the tracks to disconnect the 2 outer rails and also isolate the sections from each other. So please take a look on what I write here. More in detail, I just go to the next point now. You have seen that I'm working with 15 S88 modules which pick up the feedback signals from each traction section, from each track section, and these S88 modules have a very nice feature, very nice feature. They do not only have the S88 connectors for an S88 cable. This S88 protocol and cable have limited cable lengths of just 1 or 2 meters. These modules of the German company IEK have an RJ45 connector for Ethernet, so you can daisy chain these modules with Ethernet and have longer distances between one and the other module. This is a very neat feature and gives you much more freedom than with the cable lengths which S88 allows. On the last module, you have to use the S88 connector and feed the signals which you have captured here to either the digital model railroad command station or via a USB converter directly to the train controller software in the PC. I am using this way and not going this way with a transmission through the controller here. And the HSI 88 USB HSI stands for high speed interface, comes from Litvinsky Datentechnics, which today belongs to Bühler Electronics, and by the way, both of these companies have electronics as well for model railroading. The digital decoders which I use are mostly from ESU. There are just 2 or 3 from Märklin. How do they get their signals? The digital signals are modulated on top of the power connectors, and I told you at the beginning that the digital model railroad command or control station provides power to the tracks, and the locomotives carry a decoder and pick up the voltage with a shoe from the middle rail, whereas contactor springs pick up the ground from the outer rails of the track. The booster feeds the digital commands to the decoders in the turnouts and the decoders in and for the signals. These are photos from the decoders I use. As I said, I have around about 44 trains, locomotives, and around about 40 are equipped with ESU decoders in the versions 4.0 or 5.0. They're all sound decoders, so you can install the specific locomotive sound on them with another software on a PC. And Märklin MSD/3 is also a sound decoder which I have in my 2 big boys. There are different protocols on the market, like DCC, like MFX, like Selectrix, and others. I'm using only and really only DCC protocol to communicate from my digital model railroad controller to the locomotives. The other protocol I use is for signals and the turnouts. That's the so-called Motorola protocol, and these 2 decoders you can directly mount underneath into the C-track, as well as you could do with a signal decoder from Märklin. whereas Fissmann has decoders which you have to mount separately, but these are just for two signals. Fissmann is another electronics supplier for model railroads, but has two other brands for landscaping and building on model railroads. 15 trains of my 44 trains are passenger trains with coaches, and there is lightning in these coaches, which I control through a separate decoder in each of the trains to switch on and off the lights independently. Of course there is not much room in these passenger coaches, and there is no need to control and equip a decoder with power for any motor. So this is just a functional decoder with 4 outputs. You see here my middle finger, so that's very neat, very small, these come from the company Uhlenbrock Electronics, which is another supplier of digital controls and electronics for the model railroads. This chapter is intentionally free. I think I'll later on may add some more information about the decoder protocols. Then I just wanted to let you know that the biggest enemy of model railroad is dust on the tracks, and then if the locomotive doesn't pick up anymore smoothly the power and the commands, it will start to rattle or even stop completely. To avoid this, I have equipped each train, regardless whether it's a passenger train or whether it's a freight train, between the locomotive and the cars or the coaches with an electrical coupling. And in the following cars, here it is the first car directly after the locomotive, I have another ground spring and another pickup shoe. So you see here the pickup shoe of the locomotive, and you see here a little bit of copper, that's a spring touching the axis of the wheels. So the ground of the pole of the AC power supply is connected to the locomotive through these wheels. Very often in locomotive, these wheels are also connected internally in the locomotive with ground. So this is another pickup shoe, and this is a ground spring touching both of these axes in this first coach. And of course this one is now electrical connected through this one, whereas this pickup shoe is electrical connected through this one. So if a locomotive comes on some dust, most likely some centimeters later there is no dust and there is still power supply and smooth digital commands through this unit. And when it moves on and the dust reaches this pickup shoe, the locomotive will already have a cleaner piece of track underneath itself. Since I have done this for all my trains, I have no more stoppage and no more rattling because of dust on the tracks. And of course I clean my tracks once in a while, but I do not have to do this really every day, but maybe every other month. The electrical couplings, I use two different versions. Between the locomotive and the coach, I use a Kreuz 2-pole pinhole couplings for a very good reason. If you have the locomotive of brand A and the coach of brand B, then this supplier may have another heights above the track where this electrical coupling is connected mechanically to the locomotive. The coach may have another heights above the track, so let's assume this is, let's say, 5 or 10 millimeter above the tracks, and this is 12, then they just do not fit to each other. Kreuz, an Austrian dealer and manufacturer of railroad accessories, has specifically products, if they have this little H in the product name, this means you can adjust the couplings in H, because there is a sliding shoe back here which you cannot really see, but you can slide this whole coupling up and down across a couple of millimeters and adjust this to the counterpart coupling on the coach. And I think this is very, very neat, and this is why I use the Kreuz pickup shoes, the Kreuz electrical couplings, sorry. If I have an electrical connection to the lighting of passenger coaches, then this is comes from a separate decoder in the first passenger train, and this power is independently to be seen from the power to the locomotive, and so I need 4 poles to connect. So 2 are to connect redundantly to the locomotive, the other pickup shoe and the ground spring, and over the 2 other of the 4 pin connectors I feed the lightning power for the lights in the coaches, and this is then the coupling which I use between all the coaches. Here is again one more photo of a ground spring which is to be mounted in the wheel trucks of the passenger coaches or freight coaches, and sometimes you have to glue them in there, dependent of which supplier you just have in front of you. There's of course one disadvantage which I must mention using electrical couplings. Then you cannot decouple automatically your locomotives from the coaches or cars, and you cannot run a switching mode like on a freight train station, where freight trains get through a switching locomotive certain new freight cars. This is not possible. Everything in life has some upturn and some downturn. So far for all the different parts around my control architecture, and as next thing we'll take a look to the train controller control software which runs on my PC. Let's take a look to the components of my control architecture. First you find of course PC. This is a powerful desktop PC. Disregard the laptop, that's not anymore in use. Over here you find the digital model railroad command station, which you can use to operate the model railroad standalone without the train controller software in the PC. You can see the booster which is sitting here next to the command station, and the booster provides power and digital signals to the turnouts and to the signals. Over here I have a monitor where I have 2 cameras installed in my train depot and basement level, so I can just see whether all trains are parked correctly. I did not explain in the previous part these 2 components. The left one is an ASU log programmer, and up in front here is the test stands for locomotives. There's a little motor on, a little loudspeaker, and all this is needed to program and to test decoders which you put into locomotives, and it's just much more convenient to test this on the desk rather than always with the complete locomotive if you have to change decoders and so on. Last but not least, this is one of these S88 decoders from the company IEK with the little white connectors, which are S88 cable connectors. But as I told you, I use Ethernet cable to daisy chains all my 15 modules which I have in use. Finally, let's take a look on the two monitors, which show here screens of the train controller software. So there are different perspectives, either to configure and program train routes or to see how the trains are operating or even manually start and stop trains. We'll see this in a later chapter with a couple of screenshots.